indefinitely in different directions. Between them, there is an angle. To describe this angle, we often use the coordinate plane. We place one of the rays on the origin, extending along the x-axis in the positive direction. The location of the other ray will determine the magnitude of this angle, represented by the Greek letter theta. If this ray came about from a counterclockwise rotation, we have a positive angle. If clockwise, it's a negative angle. Up until now, we have been measuring angles in degrees, and we know that there are 360 degrees in a circle, which is what we trace as we go all the way around the coordinate plane. Why 360? Well, we aren't positive, but it seems like the ancient Babylonians were approximating a year as 360 days. Also, they used a counting system based on 60, which you multiply by 6 to get 360. And 360 has tons of other factors, so it may have been a combination of observation and aesthetics. Whatever the case may be, 360 degrees is a full revolution. But now it's time to learn another way to measure angles. Instead of degrees, we can use radians. But what's a radian? Well, if we have a circle of radius r, and we take two radii to form a sector, whereby this arc that connects the endpoints of the radii also has a length of r equal to the radii, the angle between the radii will be 1 radian. Since the entire circumference of the circle is equal to pi times the diameter, or 2 pi r, then going all the way around the circle must give us 2 pi radians, since this 1 radian is equal to a radius, and 2 pi of these will get us all the way around the circumference. 2 pi radians is therefore equal to 360 degrees. Pi radians brings us halfway around, or 180. Half pi brings us up here to 90, and quarter pi brings us to 45. In general, to convert between degrees and radians, we can take a value in degrees, divide by 180, and multiply by pi. Or we could take a value in radians, divide by pi, and multiply by 180. Try converting 30 degrees to radians. 30 over 180 simplifies to 1 over 6, and then times pi, so 1/6 pi. How about 2/3 pi? Take away the pi and multiply by 180, and that will be 120 degrees. We can also describe angles greater than 2 pi radians, or simply 2 pi, as we will often take the word radian to be implied. Say we have 5 pi. Well, 2 pi means we go around once. Another 2 pi takes us around again, and then 1 more pi puts us here. So in a sense, pi and 5 pi are the same angle. We could also notice that something like 5/4 pi and -3/4 pi are essentially the same angle as well. Whenever we have two different angles that end up at the same spot, these are called coterminal angles, and they will always differ by a multiple of 2 pi radians, or 360 degrees. Definitely make sure you understand this tutorial before moving on with trigonometry, as a comprehension of what radians are and the ability to locate angles in radians on the coordinate plane must become very easy to do. Don't worry, you'll eventually memorize most of them through repetition. In fact, this circle depicts all the angles that are multiples of 30 degrees, or 1/6 pi, and 45 degrees, or 1/4 pi. These are the angles that we will use a lot, and they are listed in both degrees and radians. If you are the type to memorize, I highly recommend setting your efforts on memorizing this, as it will make things a lot easier once we start looking at trigonometric functions.